And here, instead of machine learning, it should be written as supervised learning. In supervised learning, we have classification algorithms and we have regression algorithms. Just give me a second. Yes, now better. So in supervised learning, we have classification-based algorithms and regression-based algorithms. Now, the question is, what is classification exactly and how it is different from regression? So classification means whenever I want to classify anything. For example, if I want to know the stock price will go up or down. So there are two possible cases. Stock price can either go up or can go down. So in general, it should be three cases. Stock price can either go up or down or will remain the same. Right? So I know there are three fixed outputs that you can get. You cannot get anything out of it, right? So whenever you know the outputs, whenever you know like these are the fixed set of output, you cannot get any output apart from it. This is called as a classification based approach. Okay, what is a regression based approach? A regression based approach is wherever the output is not a single value, it is a continuous value. Okay, now what is continuous value? In continuous value, imagine it as if you want to predict the stock price of tomorrow. Now the stock price of tomorrow can be 100, 100, it can be 101, it can be 101.5, it can be 101.23, or it can be any continuous value, right? So it's like temperature, yes. So it has a wide range of values, right? So in classification, where I know there is a fixed value. Okay, in regression, where the value can vary, it's a continuous value in a specific range. Okay, so in classification, we can have discrete value. That's correct, Sumit. And in regression, uh, we have things like that, right? So in classification, we have couple of algorithms, and regression, we have couple of algorithms as well. And how I made this mind map, I was using ChatGPT. Let's be frank with it, right? And here you can see this is the exact mind map. So if I'm copying and pasting it down, that will make more sense. Uh, just to show you that, yes, you can use these tools to learn things and to teach things effectively as well. So here you can see this is what I have, right? So in classification, we have couple of algorithms. In regression, we have couple of algorithms as well. Okay. Now, if I'm talking about classification, so there are a couple of algorithms which are very specific to classification, right? And there are a couple of algorithms which are very strict to just regression, but there are a couple of algorithms that can do both classification and regression. And here you can see wherever we have written both, these are the algorithms that can do both classification as well as regression. We also have written neural networks here. I need to like fine tune this mind map so that it will not take the deep learning ones. It will only take the machine learning algorithms, but this is what we have. Okay. Now our task is to start with one of the machine learning algorithm. Okay. And the machine learning algorithm we are going to take is linear regression. Okay, this is the algorithm we are going to start with. Okay, and then I'll modify the same algorithm and give you the task to do it, to modify the same algorithm and make logistic regression on top of it. And you might be thinking, sir, here I have written machine learning algorithm, logistic regression, which is regression based, but how can we modify the same algorithm just a little bit so that we can get a classification algorithm that is logistic regression? So yes, this is maths. So you can modify a little bit and you can get a totally different value. Okay. So this is the mind map that we have. These are the machine learning models that we have. Now, do we have any other machine learning algorithm apart from them as well? Yes, we have a lot of them, right? These are the, we call them as SOTA, which is state of the art algorithms. Okay. Very famous one. Okay, some of the algorithms are way older. Like you can ask ChatGPT, like when was this algorithm first used? You might be shocked, like these are 20, 30-year-old algorithms as well. We still be using, right? And that's correct because these algorithms are still relevant, are still working. Okay, but we also have things like deep learning where we can have algorithms that are very straightforward, like in very latest algorithm that are just released. For example, transformer is released in 2017. Okay, so this is what we have, machine learning models. Okay, and this is another one image that I have attached, like which one can be used for risk classification, regression, and both. But I think this particular thing will serve the purpose. Okay, now the thing is, what are we going to do today? Okay, in today's class, our main agenda is to discuss about linear regression algorithm. Okay, we are going to write our own algorithm from scratch. Okay, so that you can have a clear understanding what exactly happens in an algorithm. Whenever I say machine learning model, what exactly do we have in a model? What exactly do we have in an algorithm? That is something we'll try to see. We'll also see the maths behind it. Okay, and at the end I will show you how you can do exactly the same thing by just writing minimal code. Okay, because we are going to do the same thing in two ways. First way is when I'm going to write the algorithm, write everything from scratch. In the another way, I'm going to use inbuilt libraries that can do the same thing for you, exactly same thing, exactly same output, but with just 2 or 3 lines of code. And here I'm going to write like a couple of hundred lines of code. Okay, so that is the agenda of today's class. We are going to write an algorithm by ourselves. Okay, but before writing the algorithm, let's do one thing. Okay, I'm going to create a table for you. Okay, so let me ask ChatGPT, and let me create a new one. So return a table. Okay, return the users, data of 10 users. Just want to give a sample with number of years of experience and their salary. Just these two things. Okay. Return data in tabular format. Now it would be great if the spellings are correct, but these algorithms are so intelligent that they can somehow take these things as well. So here you can see we have user ID, okay, years of experience and the salary. That's what we have. And for how many users, I have the data of 10 users as mentioned. So I'm going to take this screenshot and attach it here. Okay. Imagine this is the data that you have here. And you want to make a very simple machine learning model. A very simple machine learning model that can take any user. For example, if the user has 5 year experience, I can predict what would be the salary of that person. Okay. This is a very simple problem statement that we have. Now you might be thinking, sir, it would be great if rather than just having years of asking for years of experience, it would be great if can ask for designation as well, right? Or if we can ask for the location, right? If you can ask for the educational background, because for same 1 year experience candidate, we who is earning probably 3.6 LPA might be earning 36 LPA as well with the same years of experience for the same designation, right? So these kind of thing can happen, but I want to make the things very simplified. That imagine that I want to make an algorithm where based on the years of experience, I want to predict the salary of the person. This is the basic problem statement that we have. Does this make sense? I hope the problem statement is pretty clear and straightforward. Okay, how much math is required for now? Like, I'll make it as simple as I can. And but basically, you need to have some good knowledge on statistics, and on top of it, there will be some derivatives and also the things that comes into play. But I'll try to make it as simplified as I can. Okay. Now the thing is, this is the input. Years of experience is the input, and based on the input I want to predict the output, and the output is nothing but the salary. Okay, if this is just the data, definitely more data you have, the better the algorithm will become and better answer you can get. But imagine this is what we have now. Can we do one thing, right? I'm going to write a very simple machine, very simple algorithm, very simple code, not even a machine learning one, but I'll try to make an algorithm that can, based on the years of experience, that can predict the salary of the person. Okay, can you do one thing? Okay, you can also write the code by yourself. Okay, or You can also ask ChatGPT to do so. Okay, I'm going to make it very simplified, and I'm asking ChatGPT to do so. Okay, now I'm asking, uh, okay, uh, take the data of years in a list and salary in another list in Python format. Wait for my next command. Okay, so now what I'm expecting it to do, it will take two lists. One has years of experience, second has salaries. Does this make sense? Right? This is a very simplified things. I've taken years of experience and salary. Okay. Now what I'm going to do, I want it to find a multiplication factor that can map both of them. Right? I want to find a factor that can act as this and that can map this year's with this salary, this year with this salary, this year with this salary, this year with this salary. That's a very basic maths, right? And how can we do it? If I want to make one as 3,60,000, three as 6 lakhs, five as 10 lakh 50,000, eventually you need to basically divide both of them. Divide 3,60,000 by 1, 6 lakhs by 3, 10 lakh 50,000 by 5, and find the average, right? And now I'm going to do the same thing with Python. Okay, you can again coming to the same point. You can write the code by yourself as well. This is a very basic Python I'm talking about. Okay, but I'm asking ChatGPT to do so. Okay, now divide every years every year with salary and give me the multiplication factor of each and return it in a list format. Okay, and I want to divide. So if I'm going to the same part, so to find the multiplication factor, you can divide salary by years, or basically what is the dependent feature here? The dependent part is salary. Salary depends upon years of experience. So salary is something I'm going to calculate. So if salary is something I'm going to calculate, if I'm writing a very simple equation, y is equals to m multiplied by x, where y is nothing but the output, where with the salary, salary will be calculated based on what? Based on years of experience. So now what do you want to find? I want to find this salary, but so far I have the salary. I want to find this m, and to find m, I can divide it by years, right? Because if it's going from right to the left, so it will be added in the denominator part. So I need to divide salary with years. Very basic thing. So let's ask it to divide every salary with year. Does this make sense? Yes, it does. Now, your task is to do the exact same thing and execute it. Now, what it will do, it will write a basic for loop, very basic for loop of dividing both of them and give the output in this particular format. So this is what we have. So why it is returning none for one of the case. Okay. So, and here I can mention as well, run the code to get the output. Because if I'm asking it to run the code to get the output, the answer will be most probably correct. Right? So you can see it is writing the code, first of all, writing the years of experience, then writing the salary, then it will write a for loop, probably in list comprehension format or howsoever it's showing it, but it's going for both of them. And that's the final multiplication factor that it has. Now, why we are getting none for one of the cases? Because of zero. Okay, so it is zero, probably this is why we are getting none. But imagine if you don't have zero in the list. So this is the factor that I have. These are the factors that I have. Now, can you find the average factor? Like now return the average. Once I have the average, so this is the average factor that I have. You can multiply, you can take a very basic format of it, but this is what we have now. This is the number that can help you take from the input to the output. This is the number through which you can map this input with this output. Very basic maths. I'm taking all of them, dividing it into with the years. If I'm not taking zero, then it would be great, because zero is something that is making the whole thing a bit miserable for me, because we are getting some null values. But this is the final value that I'm getting. And how I'm getting it? Because I'm taking all of them and basically dividing them. That is it. Okay. And I hope you understood it. Anyone having any difficulty, any doubt, do let me know in the chats. Okay. This is a very basic maths that we are going with. Okay, and this is why I'm not even writing the code by yourself, by myself, because this is very basic Python. ठीक है, इसमें और कुछ ज्यादा है ही नहीं. Clear? Once we have it, this is the number that I have. Now what I can do, whenever, imagine if there is a new person coming in, I want, and who want to predict this, and my task is to predict their salary. And to predict their salary, what I want, I need this M, which is nothing but the parameter, and I want to multiply it with the years of experience. Now, what I need to do, imagine if there is a person coming in with 5 years of experience. What should be the salary of that person? Now, I have calculated one thing, which is nothing but M, which is the multiplication factor. Okay, so passing this M here, which is 2,19841, multiply both of them, and you will get the final result. What should be the salary of the person? It should be 10,99,000, somewhere around 11 lakh should be the salary of the person. Okay, and that's pretty simple. If the person coming with sorry 12 years of experience, the salary of the person should be somewhere around 26 lakhs. Very basic maths. Through just mathematics, I have calculated the salary of the person. Okay, and here you can see, if you check the database, do we have anyone with 12 years of experience? No. But do I have the result of the person who has 12 years of experience, and what should be the salary of that person? Yes, I have it. Okay, and now, because based on this particular data set, I have calculated a factor, and this particular factor is something that will map this input with output, this feature with label. Does this make sense? What we are doing here? This is a very basic details that we have. Okay, so this is the factor that we have calculated. This M is something that we have calculated. Now, tell me one thing. Once I have calculated this M, once this M is calculated, do I need to have this data set again? I have the data set, and based on the data set only, I have calculated this M. But once the M is calculated, do I need to have the data set again? Do I need the data set once I have M? The answer should be pretty simple, right? Once this M is calculated, I don't need data, right? Because I only need data to calculate this M. And once I have this M, I can save this M anywhere. I can save it in a text file. I can save it wherever that I want. Okay. And then whenever a new person is coming in, my only task is to take this of years of experience, multiply it with M, and you will get the salary of the person. So this is a very basic algorithm that we have made, and this is the data-driven algorithm again. This is something we have calculated based on data, right? Now the fun part is this is working. That's totally fine. But imagine, rather than taking just years of experience and salary, what if we have three things, right? Rather than just taking years of experience and salary, if I want one more thing, which is let's add years of experience and their salary, years of experience. Along with that, let me add one more thing, which is nothing but the what I would say, the degree, or let's suppose job role and their salary. Okay. Now what will happen? Now here, rather than just having just two values where just years of experience and based on that I'm predicting the salary, what if I have two inputs? What will happen in that particular case? Any guesses? If I have two inputs, now the salary should be predicted based on years of experience as well as job role. What need to be done? Okay, first of all, whenever applying machine learning algorithms, specifically where we need to perform some statistical analysis, these things can be only done on maths, on numbers. So whenever I have job roles, which is categorical in nature, which is text in nature, I cannot have these things calculated. I cannot perform any operation on it as we can on years of experience. So best thing we can do at this particular time is I will convert these job roles into some sort of numeric representation. Using some sort of numeric representation is the best thing you can do. Okay. And that's something I'm mentioning now, like convert this job role into uh, label encoding. Okay, now what is label encoding? Label encoding is pretty simple. This is a part comes under feature engineering, by the way, where every job role will be designated with a number, right? For example, data analyst is nothing but 0. Data scientist will become 1. Business analyst will become 2. Machine learning engineer will become 1. If there is a one more analyst, that person will become 0 again. Okay. Now, usually there is a better way of doing the same thing by writing rather than going for label encoding. Just go for one hot encoding. That's a better way of doing it. But now, if I'm going for it, now return just the label encoded column, years of experience and salary. Okay. Now I will be having the same data as I have here, but now this time I'll be having one extra column. So based on the job role and years of experience, I want to predict the salary of the person. Now tell me what I need to do, because this time things will be a bit difficult, because now I don't have just two columns. I have three columns. And here salary depends upon years of experience as well as job role. What should I do now? How is this calculated? This is nothing but a label calculation, right? A label calculation means by default it will take the first one, उसको 0 दे दिया, second one को इसने 1 दे दिया, and if there is a more data analyst, उसका label भी 0 ही होगा. If there is a more data scientist, that label should be again 1. Okay, this is a very basic details that I'm talking about. Okay, nothing else. I hope that is clear to you. Okay, now once this part is done, now how will my model calculate it? Now, if I go back, this M that we have calculated is just one number summarizing the whole data. This is one number that is summarizing the whole data. Here I just have 10 rows, but imagine if I have 1000 rows, or if I have 1000 rows, if I have 5000 rows or 10,000 rows, or even a million rows. It is if I have just two columns, one input and one output, irrespective of how many rows of data I have, I need just one particular parameter, one particular number that can summarize this whole data. And that's pretty great, right? If I have 10 rows, that's fine. But if I have 100 rows, 1000 rows, though the calculation will be much higher, but I will be having this particular number that is summarizing the whole data. This number is nothing but what we call it as a parameter. This is a parameter. Just 219841 is one parameter that is summarizing this whole data set. Okay. And whenever, if I'm treating it as a machine learning model, so this is a machine learning model, but inside this model, what exactly do we have? We just have one number. That's the brain behind the model. We have one number that can summarize this whole data set. Okay. You can treat it like a knob that you might have used a radio, right? So in the radios, we have two knobs. One is for volume, another one is for frequency. Let's talk about just the frequency one. That's something going to take you the final value. You need to keep on tuning these knobs unless you have found a perfect value, right? And imagine rather than just having one knob, if you have two knobs, thing will be a lot more complicated because we need to go for all the combination of both the knobs. Then only you can get a perfect fit to get the value. And the same kind of thing also the companies of locker companies also using to go for the locks. You might have seen a couple of movies, and not in movies, you might have seen in your home as well. Okay. Now imagine, just rather than just having 2 or 3 knobs, if you have 100 knobs, if you have 1,000 knobs, if you have 1,000,000 knobs, and if you have 1 billion knobs that you need to keep on tweaking or keep on tweaking to get the best fit for your data. And this is exactly how machine learns. If you have heard about ChatGPT, ChatGPT has billions of parameters, right? Or GPT model has billions of parameters. Llama has released their own uh, open source model that also have billions of parameters. Okay. And now we have made a very simple model with just one parameter. So whenever talking about what are the 6 billion parameter means, 6 billion parameters means the model has 6 billion numbers into it. And usually they are not integer numbers, they are floating point numbers. And in floating point as well, it is 32-bit long after decimal, 32 digits after decimal. This is how long these strings are. Okay, this is how long these this floats are, not strings. Okay, I hope you have a clear understanding now. What exactly is a parameter? A parameter is something that we will calculate based on the data. And once it is calculated, I don't need data. I have the calculated field, I have the parameters that will help you do the exact same thing. Okay, now here I need one parameter, but in this particular case, I need two parameters, the multiplication factor of this one and this one. Okay, and if you know a bit of maths, and if you might have seen this particular equation, this is y is equals to m multiplied by x plus c. Exactly don't predict salary, right? But these parameters exactly don't predict salary. Yes, this multiplication factor has nothing to do with salary. This m factor, even this algorithm that we have written, don't know that we are predicting salary. For this algorithm, the funda is pretty simple. Whatever number coming in, multiply it with this particular number and you will get the answer. That is it. Irrespective if you are getting years of experience, if you are getting the salary of the person, even if like you can give the uh, the age or to any number, give any number to the age. The main funda is that that value will be multiplied with the parameter and give you the result. That's it. Okay. And this is a very simplified calculation that we have done. Okay. And this is nothing but the equation of a line. Okay. So y is nothing but the output, which is something you will get as a salary. X is nothing but the input. M is the factor that we have, and C is the intercept. Okay, we don't have enough time to discuss about intercept and slope as well, but I hope you know that like this is basically showing the equation of a line. This is the equation of a line that we have. Okay, and in this particular part, I'm not taking the C part of it. If you are taking the C part of it as well, the output would be a lot higher. Okay, but in that particular case, you need to calculate two things. You need to find not only M but C as well. Okay, this is a simple part here, but to find it the same thing in this particular case, the formula will be a bit different, because here the formula would be M1 X1, because this is first input, this is the second input, and this is the output Y. Wherever I'm saying X, I mean to say input. Whenever I'm saying Y, I mean to say output. So this is X1, just to show you so that you will remember. So this thing will become X1. This is X1. This is X2. And this is your Y. And once we have this, the formula to find it, it means the final formula to calculate the salary is M1 multiplied by X1 plus M2 multiplied by X2 plus C. So here, how many multiplication factors do we need? You need to find this M1 and M2. Exactly the same thing that I have mentioned. Here you need one parameter that has to be calculated. In this particular case, I have two parameters that has to be calculated. Okay, and to be more specific, to get a better result, you need to find three parameters. So now to summarize, if I'm talking about the linear regression algorithm only, now I'm coming to the point that this is how it works. Linear regression algorithm will is used for linear relation data, first of all, where there's a direct relation into the input and the output. But the funda will be pretty simple. Here, you need to draw a line that can summarize the whole data. You need to draw a line that can summarize this whole data. Okay, and here in this particular case, to find that summary of the line, you need to calculate M and C. And here in this particular case, M1, M2, and C. If I have three inputs and one output, then in that particular case, X1, X2, X3 are going to be the input and Y is going to be the output. So in that particular case, the formula would look something like this. Can we get this doc? Yes, you will be getting it. So in that particular case, you will be getting M3X3 plus C. So how many parameters you are going to have in this particular code? In this part, you will be having four parameters that has to be calculated. First parameter is M1, M2, M3, and C. Okay. Now, the final goal of my algorithm is to calculate these parameters. Okay. And in some advanced algorithms, you also have like millions or billions of parameters, as I mentioned as well. There will be a lot of other factors as well, just rather than going for this part, but this is how it goes. Okay. So whenever someone said that, okay, tell me what are the parameters we have in machine learning. So parameters are nothing but a trained model, what a trained model is storing. And a trained model is nothing but storing numbers, floating point numbers. Okay, sometimes they are just one array of numbers, sometimes they will be multiple array of numbers. And whenever some data coming in, the operation will be performed on the incoming data based on the trained model, and then you will get the output. And this is what it does. Okay, now I hope you have a clear understanding what's happening now, and you can do the same thing here as well. But here the issue is, if if you want to calculate the C part as well, so now this is going to be a quadratic equation. Okay, because you need to calculate the C part as well. There are two variables that has to be found. Okay, now to find these two variables or three variables or four variables or how many variables do we have an algorithm that can help you do so. And the algorithm is called as gradient descent. Okay, and now I'm coming to the main coding part. Okay, now what do we have in gradient descent? Let me showcase the code to you, that what exactly we are going to do. I'm using a data set which is of diabetes. This is of diabetic patients. Okay, and I'm using sklearn library to load the data set. I'm also using matplotlib and numpy to load the data, to load some of the add-ons things, such that like whenever I want to do plot the graph or perform any numeric computations or array computations, so it would be easier for me. I hope you guys are already aware about NumPy, Matplotlib, and sklearn. If not, you guys can go to YouTube Geeks for Geeks, and there will be plenty of sessions that you can get. Like a NumPy series, something I've made probably 2 years back. It's available on Geeks for Geeks channel as well. You guys can check that out. Okay. Now the funda is I've executed it and I've executed this part. Okay, now what's happening in this particular part? Let me add a new code cell here. Okay, and those who are not very much aware about where exactly I'm writing the code, I'm writing the code in an environment which is called as Google Colab. Okay, this is a pre-written notebook, but you can also create your own notebook and write the code for you by yourself. I'm going to share this particular file with you at the end so that you guys can also try it by yourself and check how much you know and what are the things that you can find on and things like that. Okay. We have to do with you now? No, that's totally fine. You can do it after the end of the session because all the whole code is pretty much sorted. If you are running it, it will run. Okay. So the funda is if I'm going for data of data. Now, how will you get to know I need to go for data.data only? Because I've loaded data. If I'm executing data, here you can see it is starting with a key value pair. So it's nothing but a dictionary, right? Those who already know Python, they can see. So if I'm writing data.keys, so these are all the keys that I have. So I can access data, targets, frame, description. So if I'm finding DSCR in this particular way as well, you can find it. So this is the description of the data set. So if I'm printing it, because this is the raw format that we have, this is what we have. So in this particular case, you can see like this, these are the details of the data set. These are the columns we have. These are the columns we have. And first 10 columns are numeric predictive values. Number of instances, we have the data for 42 patient, and the value that we need to predict the diabetics or disease progression. Okay. Diabetes data set. This is our diabetes data set. So you are going to predict the final diabetes of the person, diabetic value of the person. These are the inputs. How many inputs do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 inputs. Based on 10 inputs, you need to predict one output. If you go back here, this data set has two inputs, one output. So for two-year input, one output, this is the formula. For three input, one output, this is the formula. Now imagine what would be the formula if you are predicting it for 10 inputs. So it would be m1x1 plus m2x2 plus m3x3 up to m10 is to x10 and plus c. There will be one single intercept that we have. Okay. So in that particular case, how many parameters do we need to calculate? Do give me an answer in the chat. How many parameters do you need to calculate in this particular case where I have 10 inputs and one output? In the case of 10 input, one output, so m1 x1, m2 x2, m3 x2, because we have 10 inputs, so there are 10 m's that we need to calculate. ये तो direct ही हो गए, but there is one c as well, right? That you need to calculate. So total number of parameters are not 10 but 11. 10 are m's, 10 m's you need to find, and one bias as well you need to find, or intercept you also need to find. So number of parameters are 11. In the case of this one, if the formula is pretty straightforward, here you can see I need to find m and c to get a better answer. You are getting it for m as well, but whenever going for two or multiple of them, adding c part into it will give you eventually better result. Even for single one, you will get, by adding c part into it, it will give you a better result. Okay. And the issue you are facing with zero will be overcome if you are using the zero part into it as well. If you are adding the c part, this particular issue will also be resolved. Okay, so this is why we need 11 parameters here. So let's go back to the code and see how these parameters are being handled. Okay, so far I'm just loading the data and splitting it and transforming it. But now let me tell you what exactly is happening here. So if I'm showing you x, so x is nothing but the whole data that we have. Okay, and let me, rather than going for the x here, let me show you what do we have the data exactly here. So these are all the columns that we have. And if I'm going for data of data, this is the data that we have. You might be thinking, what exactly do we have in this data? Okay, so let's do one thing. Let's check the shape of it. The shape of it is 442 is to 10. That means there are 442 rows and 10 columns. And that's exactly what we are expecting, right? Because this data is of 442 patients. So 442 rows and 10 columns is something that we already have. Okay. And if you want to show the data of the first patient, you can go for indexing. And these are the first, this is the data of first patient. This is the age, this is the sex, this is BMI, this is BP. You might be thinking, okay, ये यहाँ तक कैसे पहुंच गया? Age should be in integer format, right? How can age be in the decimal format? So that is something we are doing because we have feature engineered on this. In tomorrow's lecture, we are going to build a whole pipeline or project. This is just to know how algorithm is being applied. So that part is something I'm skipping for now, that the data, how the data is normalized exactly. But this is exactly what we have. Why we are doing it, why age is in this particular format, and sex, how sex can be written in this particular format. Okay, because all these values are normalized in such a way that all these columns will have the same range of values, because age can have 0 to 100, sex can have 0 to 1, BMI can be another number, BP can have another range. So normalizing will return all of them with the exact same range between -1 to 1. Okay, so this is the data of first patient, and what would be the label of it? And to print the label of it, it would be data of target. of 0. So this particular patient with these particular details has a has a diabetic number of 151. And what if for the next patient 75, for the next patient? So this is nothing but, if you can imagine it as a data frame. So I have 442 patients with 10 row as an input and 1 row as an output. 10 row as an input, 1 row as an output. Always range from -1 to 1. Yes, because machine learning algorithms, okay, machine learning algorithm can work even if the range is not between 0 -1 to 1 as well. If the range is between 0 to 1 as well, then also it will work. If the even if the thing is, if the number is -4 to 4, then also it will work. But usually it should be a normalized format. Whenever the data is normalized, it comes into standard deviation range, and standard deviation range is -4 to 4. Okay, so if I'm talking about like uh, bell curve, and okay, so if I'm talking about standard deviation, here you can see the data. Usually in this particular format, the data is between 0 to 3 standard deviation and 3 standard deviation positive. So it should be in the range of this particular kind of a scenario. So between -3 to 3, -4 to 4, that's the maximum we can go with. Okay, but usually it should be in the range -1 to 1. Why exactly -1 to 1? Because as I've told you, in deep learning algorithms and or in neural networks, whenever each parameter is calculated in a decimal format, and the decimal is very long. It's a 32 digits after decimal as well. And whenever this deep you want to go, the best thing you can do is go for floats, right? Going for float is the best thing you can do. So going for float is the main reason why the value should be very close to 0. Okay, a bit more, a bit lesser than that, that's totally fine. And there is a benefit of using machine learning algorithms as well, because in machine learning algorithms, for some of the algorithms, even if are not normalizing the data into exactly the same range, but they should be not very close to 0, that also fine, because the algorithm will predict it. Okay, but for deep learning algorithms, it will not work. Okay, so this is the data that we have. So all the data of 442 patients is something that I have here. Okay, now the question is, I'm going to take this data and find M and C's. This is what we need to find, right? How many M's you need to find? You need to find M comma N. Okay, if I'm printing X dot shape. Okay, but to print X dot shape, first of all, let's discuss about one more terminology that we have. And the terminology is pretty simple. Whenever you are training a model, you will not give all the data to the model to train itself. Okay, because I want to evaluate the model as well. And to evaluate the model, the best thing is you can divide the data into two chunks, 80% for training your model and 20% of it on which you have not trained the model. We are going to use that 20%, that remaining 20% for test the data. Yes, this is correct, Subi. This is train and test split. Okay, this is exactly what we are planning to do. Okay, you can think of it as whenever you are going for a class test. Okay, how will you check if the person is intelligent or not? If I will ask couple of questions which are not from the syllabus, which is something that you have not trained on so far, and if you can answer those questions, then only you can see. So best thing I can do is, rather than giving you all the question to train yourself, i'll I'll take couple of questions to myself that I've not broadcasted to you. And then out of box is something that I'm going to give you. Means out of box means the question on which you have not trained. So the same kind of thing I'm also doing here. So I'm taking this data set and doing a split of train and test. Okay, now what is this train and test? Here you can see this is point 2 mentioned here. Point 2 is nothing but we are splitting the data of 20% for testing and 80% for training, right? So if I check the original data set, so original data set has 442 rows. So 442 rows are for training, and after that 353 are for training now. In total, we have 442, but now I just have 353 for training. Now, where exactly do we have the remaining one? The remaining one is something I have it as test data. Okay. So a remaining one is something I have at test data. So if I check the shape of it with the correct spelling of shape of course. So I have 353 rows on which I'm going to train my model, and remaining 89 rows where I'm going to check if my model is predicting the output correctly or not. Okay, so these are the inputs that we have. So basically what I have done, I have taken the same data set. Okay, where I have the same 442 rows and 10 columns. I have taken 353 rows for training and 89 for testing. And these are the inputs. So I must have the output as well. So the output for X is Y. Output of X test is Y test, right? So output of, so if I'm checking Y test, it will be labels. So just 89 values here. And if I'm checking Y dot shape, this is the output here as well. So this is the output of first row. This is the output of first row of test data. Does this make sense? So we are splitting the data. And once the data is splitted, my task is pretty simple. I need to take this X. What is this X? This is the X. And check the shape of it. The shape of it is, it has 353 rows and 10 columns. On this particular data set, I'm going to train my model. So because it has 10 columns, so this 10 value is something I'm saving. So if I'm writing X is equals to M comma N, this 353 will be saved here and 10 will be saved here. So N is storing the value, which is nothing but 10. Now, how many weights I need to have? I need to have 10 weights and one bias, because M1, W1, M2, W2, M3, W3 up to M3, M10, W10. So I'll be having 10 weights and one bias. So based on this exact same thing, if I'm writing NP dot zeros of 10, so it will give a giant array of just 10 values. It's starting from random and one bias. So what I need to do exactly, just to give you a brief, I'll take X of 0, this data, multiply by this array. So this multiply by this multiply by this multiply by this, just a basic dot product, and add a bias to it. So this whole thing multiply by this particular array. And if you are performing dot product of it, my means by multiplying both of them and by adding just and after that adding it, and after that adding a bias, the same thing will happen. The same formula will happen. Y is equals to M1, X1, M2, X3, M3, X3, and so on. So once this part is calculated, what we are going to do, we'll check the existing weights and biases. And by default, you might be thinking why all the weights are something 0. Because by default, I am initializing the weights as 0. Once the weights are initialized, I will go through the dataset and update these weights and make the final weights as the final hero. Right now the weights are zeros, but after doing all these calculations, there are a couple of like this where the calculations are happening. These are going to be the final weights, and this is going to be the final bias. That eventually, if there is a new data coming in, I'll multiply that data with the weights, add them with the bias, and you will get the final prediction of the person. Right? So what are these weights? What's happening in these weights? These weights will be calculated throughout the process. And now we will find what exactly the process. Okay. Can you explain the weight part again? Yes. So let's summarize whatever we have discussed now in terms of weights. The data split part is pretty clear, I think, for you guys. Okay. Now what I'm going to do, I'm going to find this particular scenario. In this particular scenario, this is what we have. But here, I need to find M1 multiplied by X1 plus M2 multiplied by X2 plus M3 multiplied by X3. And I need to do it for all of them, right? Do it till M10. Okay. Because I don't want to write it for all of them. Let it write for me. So this is going to be the final formula. This is how the final formula will look, right? And this is not only till M10, you need to also add a bias on top of it as well. So this is, imagine this is the final formula that I have that I'm adding here. Okay. And okay, it would be great if it is here only, because I need to go back and see. But this is going to be the formula, and we need to add a final bias here. Now we need to calculate what? These M's, M1, M2, rather than defining them in a separate variable, that this is M1, this is M2, this is M3. I've added all of them in one giant array. This is M1, this is M2, this is M3, diff M4. This is X1, this is X2, this is X3, this is X4. You might be thinking this is X, this is another X, this is a variable X, which is storing all the rows of the data. But if I'm talking about just first row, for this particular, this is the first value that has to be multiplied with this value with this value with this value with this, and so on. Okay. And by default, I am starting initializing weights with 0. And throughout the process that I'm going to use, this process will find the weights. And these are the final weights that we have. Okay, I hope this particular part is clear to you. Now we'll go ahead with how are we exactly going to find the weights. Okay, shall we go ahead? And here comes a little bit math about it. Okay, shall we go ahead? Do give me a yes. Yes, everyone. Okay. Okay, great. So now the funda is pretty simple. Now, what do we have in M? Now, don't get confused. Okay, there are some naming conventions that I have changed a little bit. Now, W is something storing all the weights. Okay, M is number of rows, N is number of columns. So how many weights? 10. How many bias? 1. So how many parameters in total? 11. Parameter will be number of weights plus number of biases. Okay, bias will be 1 only. Weight will be multiple as per the number of variables that you want to count. Okay, so can I say the formula that I have mentioned here? Okay, add B here as well and replace M with W. Okay, so that I can add the final formula. But if you look closely to the formula, okay, let me go to the formula only, then only it would be easier for you. I can use this way, if not directly copy and pasting it. Okay, so if you look at this particular formula, okay, because this is the data that we have. So I have how many weights to calculate? I have 10 weights to calculate and 1 bias. Okay, and if you look closely, I need to add 10 weights and 1 bias, can I say this is the formula? Can I say this is the formula that is defining this exact situation? Or not situation, the correct word should be equation. Okay, this equation is giving you the exact same thing, right? We need to find it for all of them. And here n is nothing but 1 to n. N is nothing but from 1 to 10. This is the exact same equation that I have, right? So right now we have random weights, random W's. So if I have random W's, so based on random W's, but actual X and a random B, I will get an output for sure. But the output will not be correct. Output सही कैसे हो जाएगी? These are random values, right? So I will take first of all these random value. Okay, and that's the formula that will help you do exactly the same thing. I will take all the x's, multiply them with W, which is random weights, 0, and bias, which is random as well. So the output would be, the error would be huge, because eventually I will get the output 0, because all the x will become 0 here by multiplying with 0 and plus by 0. So all the output will be 0. So for every patient, the output you will get, the diabetes value you will get is 0, because eventually you have W and B 0. But now what we are going to do, this is the equation that I have written to define the cost. Okay, just don't get confused with it. This is nothing but a function that we have written. Okay, this is the predicted value that we will calculate from random value of W and B. Okay, this is the actual value of Y, because this is also something that I already have, because this is a labeled data. I know the input, I know the output. So based on the output, this is the actual output that I have. This is the predicted output that I will get based on random M and B. Now I'm finding the square error in between. Subtract them and find how much error do they have, how closer these values are. If they are not very closer, I want to make them closer, because what exactly will happen if a patient is having exact diabetic value 150, but my model is predicting 0. So 0 minus 150, the error is 150, right? Or minus 150, right? So I need to minimize this error. And to minimize this error, this is the function that I have written. And using derivatives means this fund will have two variables that has to be calculated, right? Or change in two variables that has to be calculated. Okay. And this is where you need to have a bit of knowledge in derivatives. Okay. You need to find two values, W and B. So I need to take the same function and do the derivative of it with respect to W and with respect to B. Okay, if you look closely, what will be the derivative? Now, why I'm having 1 upon m, so that what is m? M is the total number of rows. So whatever error you will get by writing 1 upon m, you will get the average error per row. Why 1 upon 2? Because this 2, whenever doing the derivative, 2 will become in front and 2 and 2 will cancel out. That's it. Okay. And now, if I am doing the derivative of it with respect to W, this is something that you will get. Okay. And those who know a little bit of derivatives, so they know about the chain rule as well. Okay. And same goes here as well. Now you might be thinking, sir, why I'm having x1 here, but not x1 here? Because here, if you look at the equation, this is y1. How is y1 calculated? Based on this. So the final equation would be 1 upon 2m, this whole thing, xi wi plus bi minus yi. Means you will calculate this whole thing here. So in place of it, you will be having xw plus b minus yi to the square. Now, if I'm doing the derivative of this with respect to w, so x is a constant, b is not. So x will be there. If I'm doing it with respect to b, this whole thing will be vanished. So this is why we have x part here. This is a very basic derivative that we have. Okay. Which one is predicted and actual? Wherever you have hat here, this is the predicted one. This is the actual one. Okay. So this is the function that will tell you how much W need to be changed. This function will tell you how much B need to be changed. Simple, right? How much W need to be changed, how much B need to be changed, and how to write the same thing in terms of functions. This is how to do it. This is how easy it is, right? 1 upon m dot product x with the error I have mentioned. And instead of error, I have written y minus y over it. So you can also place it here. That's also totally fine, right? And that's the same formula that will give you dw. Now, what is this dw? This whole thing. What is this db? This whole thing. And that's it. It will tell you how much w need to be changed, how much b need to be changed. Does this make sense? And once you have done it, eventually what you need to do, you need to update the current W's and B's, because this Y hat is something that is calculated based on existing W's. Existing W and B are 0, right? Now I will change the existing W's and B's. This is what has to be changed, in which direction we need to move, right? How much W and B's has to be changed. And now I'm going to take the existing W's and B's and change them as per this particular formula. And to change them is this particular formula. Here you can see we have alpha here. Alpha is nothing but a learning rate. This is the this is the coding way of writing the same thing. Pretty simple, pretty straightforward. But the thing is, what is this alpha? This is learning rate. What is the use of learning rate? Yes, it is 0.01. I've mentioned here, like somewhere must have mentioned. Okay, not right now, but probably I'll mention after that. Okay, here I must have mentioned it. This is the learning rate that I mentioned. But what is the learning rate? At which rate the model will learn at each epoch? So learning rate, yes, we can see it this way. But basically in learning rate, so imagine in the first step, the error is 170. Okay. In the second step, the error is 3. In the third step, the error is 50. So if I'm writing dw is equals to w, the change is directly w, means whatever change that has to be happened. If I'm replacing that change in the and updating in existing w, se hoga kya? W will be very steadily changed. Very rapidly the W will change. I don't want to rapidly change W. I want to make a smaller step so that I'll have a smooth transition to get best weights. Okay. And to do that, the best thing you can do is take the exact same thing and by adding a very small learning rate factor, very small factor, which is alpha. And this alpha is nothing but learning rate. Okay. And I'm taking this very small learning rate, multiply them with the existing factor that we have and update the weights so that the weights will be updated very steadily. Okay. And this is what we have. This is how they are being updated. And here I mentioned learning rate as well. Now, eventually the same step has to be happened multiple times. Okay. So that means if I go here, this is the second step by adding it here. Okay. So first of all, I'll find yi. Based on yi, I'm going to find these new weights and biases. Based on these new weights and biases, I'm going to check what exactly need to be changed. What are going to be new weights? Okay, this will tell you what has to be changed. This will tell you the new weights and biases. And by default, these weights and biases that you existing that you have right now, by default, these weights and biases are initialized with 0. Right? First of all, I'll initialize the current weights and biases, which are 0. And once they are initialized, I'll calculate the error based on this. I'll find the change and I'll do this. So this is the 3-step process that I'll follow. And that's pretty straightforward, right? This is step number 1. This is step number 2. And this is step number 3. But not that simple. Okay. So this is step 1. This is step 3. And this is what we have. Now, on top of it, you need to update it, keep updating it. Okay, this step 1, based on that you will find this, based on that you will find the new W, but you need to keep on updating it. And you need to keep on updating it until unless you are getting correct outputs. And to keep on updating it, you need to pass the exact same thing in a loop. So you need to pass this thing in a loop and you need to do this iteration multiple times, couple of hundreds or couple of thousand times. And same thing is happening here. I have passed this whole thing in a for loop. For how many times? Number of iterations. Means how many times you will go through the whole data set. I'll find the predicted values. By default, weights are 0 and bias is 0. So what I'll do, I have defined the learning rate. I have defined the number of iteration for how many times you need to go through the whole data set and check the errors and update the weights. So how many times weights will be updated? The number of time this loop will work. How many time loop will work? 10,000 times. So 10,000 times weight will be updated, but very steadily with very small steps at a time. And if you look closely, first of all, I'll find by predict. Then I'm printing cost. Why I'm printing cost? There is nothing to do of cost here. This is just to print them. That the cost should be minimized. The actual value and the predicted value for both of them, the cost should be minimized. Then only we can see the model is learning. Okay. Even if you are not running this, then also your model will work. But this is just a way, this is just to show you that if your model is learning or not. Okay. So this particular number that you can see will tell you the about the cost. This one is the second step, as I mentioned here. the error that we need to find. The third step is updating the weights. So here I am updating the parameters. For that purpose, I have already have a function which is called as update parameters. So I'm getting new W and B. So I have initial W and B, they are changed. Then I'll calculate again, change them again, change them again, change them again. Every time I'm done with 1000 iteration, I'll print the history and print the current weights, or basically save the weights in the weight format. That's it. Okay. So now if I'm executing it, basically I need to run all of them. Otherwise it is going to throw in error because in between cells I have not executed. So here you can see in iteration number 0, I started with this error, but then it start decreasing. And here you can see it is decreasing at a rapid rate, so it will still decrease. So you can go for a couple of more iterations. Okay, shape. Okay, let's run it again. I don't know why exactly it is going an error. So here you can see this is what we have. So model is being trained, and here you can see this is the minimum error that we have got. Now, if I print these parameters, now what are these parameters? I have initialized a dictionary. Inside this dictionary, I am saving key as weights. This W is nothing but the array that we have, the weights, right? I'm converting the weight to a list. So if I open this dictionary, I will be having these parameters, and these are the parameters that I have. These are the weights, and this is the bias. Pretty simple, right? So now the funda is pretty simple. You can save this parameters in a JSON format. So if you go back here, here you can see these are your parameters. You can download this. This is a model that you have. Very simple model. Now what I can do, I'm here in this particular case, what exactly I'm doing, just want to show you. I'm going for X underscore test. If I'm going for test data, this is what we have, right? This is X underscore test. This is what we have. How exactly do we have it here? I think I might have changed the code a little bit, but if I am okay, I need to run this whole thing again. So here you can check. This is what we have. This X test. This is unseen data. So I can take this X test. Here I'm taking first 10 random rows. Take S test. I'm taking first 10 rows of testing data, doing a dot product of it with the existing weights and adding bias into it. Y is equals to mx plus c. But now doing the same thing for first 10 rows, so that I am printing the inputs, the exact outputs, as well as the output predicted by my model. And this is how my model is performing. Actual output of that patient should be 219, but mine is 150. But I've trained my model from scratch. This is not the great model that is giving you the perfect output, but this is working. Right? So this is exactly what a model is. What does append function do? Append function will basically append the value into the list. Okay, so if I go back, what exactly it is doing, here you can see there's a list that I've initialized named as cost history. So whatever data we can see here, the same data you can see in the cost history function as well. So this is a list which is storing how the list is changing. So what you can do, you can write, for example, this just want to show you why exactly I'm doing it. Okay, code to plot this data in a line graph. And now my agenda is that the cost should decrease. And let's see if the cost is decreasing or not. And you can see cost is decreasing. This is exactly what I want. Right? So loop is using training data, right? Yes, loop is using training data. But this one, if I'm talking about, this one using test data. This for loop using this data. So first of all, now if I want to show the whole pipeline and summarize whatever we have done in this lecture, or specifically in training the model, I have the data set. Inside the data set, I have taken two things. Let me zoom a little bit in. I've divided the data set into two parts, training and testing. On training, I'll have training data, 352 rows, I think. And in testing, I have 20% of the data, which is almost 80, 90 rows. Now, once I have it, I have initialized random weights and biases as shown here. Okay. And before that, there should be one more step that I should be adding, which is initializing random weights and biases. And once that part is done, once these random initialization of weights and biases are being done, after that, the repetitive task should be till here. There are only these steps keep on repeating, not initializing the weights and biases. Because initially, whenever I'm initializing the weights and biases, is 0, bias is equals to 0 again. Rather than weight is equals to 0, it is nothing but an array of zeros, and usually they are 10 values. And let's calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So first step is to initialize the weights and biases. Once initialize weights and biases, calculate the error and keep on repeating this process until and unless you found the best weights and biases. And that's it. Increase the width of it, and this is what we usually do. Okay, and this is the process that will keep on repeating. These three steps will keep on repeating, not the rest of them. Okay, and we started from here, as you can see. We started from a very basic model, that how we can make one-to-one relation with just one M. And then we have discussed how we can do the exact same thing. What will happen if I'm having two of them? Okay, then we can see what will happen if you have the data that looks something like this. Okay, and here just to make the things a little bit easier for you to visualize, I can also do one thing, that whenever I'm taking X and whenever I'm taking Y, I can ask Gemini to code to display data of X and Y in data frame. Okay. Now it will write the code for me. Now, definitely I can write the exact same code by myself as well, but okay, why to do if we can use Gemini to do so. So here is exactly what I have done. This is the exact data that I have. These are the input, this is the output. These are the features, this is the label. And if you want to show just first 10 rows, this is the data that I have. So let's take a screenshot now and let's paste it here. So in this particular case, especially to run this specific thing, this is the model that I'm going to use. This is the formula that I need to use. So here I need these many weights, these many biases, and to do exactly the same thing, how exactly I have done, I have used this specific approach of updating the weights and biases. So this is what linear regression is. This is what linear regression algorithm is. Okay. So hope you guys are clear with it. Okay. And so this is day one where we have discussed about introduction to machine learning. Let me add all these things in this as well, so that it would be easier for you to understand what exactly we have done day by day. So this is day one of the lecture with introduction to machine learning. And now in day two of the lecture, this is exactly what we have discussed. It's definitely a bit more discussion that we have done as compared to the last lecture, because last lecture is more of the theoretical part. Here we have discussed the practical implementations of it, practical aspects of it as well. So this is day 2 of ML models. Okay, great. Now let me share all the support files with you so that it would be easier for you to go ahead. So this is day one where we have discussed about the theoretical aspects of it, and this is day two where we have discussed not only this particular part but the coding part of it as well. Okay. Now, how can you access this particular file? Now, to access this file, there are many ways, and I'll tell you a very simple way because this file is of no use. So let's not put it in trash. What you can do, you can search Ashijanga here, go to the first link, go to repositories. Okay, I'll share the link at the end as well, and go for machine learning from scratch. There is a repository named as machine learning from scratch. Go here, and this is the exact code file which I have used. What you can do, you can download this file through here and upload it on Colab and run it. Okay, and you can see this is exactly the same code that we have discussed. And this code is exactly with markdown. So this is a full code for that. Okay, we have done the discussion till here. We have not done the discussion after this, like how exactly we will get the predictions and what are the different ways to calculate the model, evaluate the model. That's something we are going to discuss in the next class. Okay, and here there is a bonus part as well, how you can run the exact same thing that we have done for defining everything, but using how you can do the same thing using inbuilt libraries. So this is stochastic gradient descent only to perform linear regression. And this is how you can do the exact same thing with just one snippet of code. Okay, so this is what we have. That's the code file that you need to take. So I'm copying this file and save it in Excalibur so that it would be easier for you to access it. Okay, so here I have added the Excalibur file link. So you need to copy and paste it here, and eventually you will be able to use it. Okay, and what else you will be needing? You will be needing this Excalibur link. Yes, so let me share this link with you. Copy the link, and here is the final link. Okay, so here's the final link shared with you, which has all the notes. So please check it. This is the final link with all the notes, and inside this notes only, we also have this. Okay, can you please recap the cost? Yes, for sure. The cost is pretty simple basically. Cost is nothing but finding how So sorry guys, there was some electricity issue happen here. So this is something that we have discussed so far, and I have shared the link with you as well. But let me share it with you again. Mm, 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 mm. So that is it for today's class. In the next class, which is nothing but day 3 as well, we are going to discuss about what else do we have, how we can make a end-to-end machine learning project. Because here you can see we have made a project, for sure we have made a model, but our main agenda is to know what exactly a model is, how a model learns. We have discussed specifically about linear regression. There are a lot of other algorithms as well for which we have not discussed yet, because if you want to dig deeper into what a machine learning is, what an algorithm is, what a model is, what a parameter is, stick to one algorithm and dig deeper into it. We can have detailed discussion, or we can have discussion on 5 different algorithms, but will not catch exactly what one algorithm is doing. So it would be great if we can have discussion on one algorithm in detail. And that's something we have discussed in this class as well. We started with linear regression. This is the process. And this is the GitHub link that I have added in Excalibur as well. In the next class, we'll discuss about a project. We'll build a end-to-end project and we'll see how we can deploy it as well. That's the part of next class. Okay. So thank you so much everyone for joining in. Yes, Deepak, you can have it. Yes, we are going to discuss about that as well. So, Man, Faisal, thank you. Great. Okay, that's great. Okay, recap of cost. Cost is nothing but just to see if your model is performing or not, because eventually we are printing this cost and that should be minimized. If you are not printing the cost, calculating the cost, that's also fine. It's basically a progress track if your model is learning or not. Attendance link, sorry, I don't have the attendance link. It will be automatically marked, I think, because you have joined from Zoom, right? So it will be automatically marked. Okay. Why do we split the data? So that we can give an unseen data to my model and check. It seems like why you are not getting question from the notes that are shared with you by your schools, because this is not exactly how they can check your intelligence. In the final exam, in entrance exam, there need to be a couple of questions that are out of syllabus. Then only you can check for better predictions as well, to check if your model has not crammed the data and knows how to do it. Okay, so go for the recordings of this session, go for the Excalibur, and these are the lecture notes. Okay. And yes, that's it. I'll see you in the next lecture. Then take care, everyone, and take care, everyone. Bye.